Special cases of compound inequalities. A solution of a compound inequality joined by and is any number that makes both inequalities true. When there's no number that makes both inequalities true, we say there's no solution. A solution of a compound inequality joined by or is any number that makes either inequality true. When all numbers make the inequality statement true, we say the solution is the set of reals or all real numbers. Suppose we solve an and compound inequality to see if the two inequalities have an intersection. So we have 2x is greater than or equal to 18 and negative 3x is greater than 12. Solve both of those for x and we see x is greater than or equal to 9 and x is less than negative 4. The solution set for each inequality does not intersect. This is a no solution case, since there's no numbers that are both greater than or equal to 9 and less than negative 4. We write the solution set as a null set, so empty curly braces or a O with a line through it. Solve an or compound inequality to see if all the real numbers are contained in the solution set. Alright, here's our two inequalities. Negative 2x plus 3 is greater than or equal to 17. When you solve this for x, you get x is less than or equal to negative 7. Over here, we have 5 times x plus 2 is greater than negative 40. When you solve that, you get x is greater than negative 10. If I just draw a quick sketch right here, here's negative 10, here's negative 7. X is greater than negative 10 would look like this. And x is less than or equal to negative 7 would look like this. You can see that all numbers work. The solution set is all real numbers, since all real numbers are either less than or equal to negative 7 or greater than negative 10. The solution set is written as this special r, which is an r with an extra line on the left side. The two inequalities are combined on the lowest graph to show that all real numbers are the solution set. Even though the number 10 is not in the solution set of x is greater than negative 10, it is in the solution set of x is less than or equal to 7. So it is also in the compound inequality, negative 7 is less than or equal to x, which is greater than negative 10. Outside of this intersection, the rays go to negative infinity and positive infinity. Solve each set of compound inequalities. All right, here are the first two inequalities. When we solve the first one for x, we get x is greater than 6. And if we solve the second one, we get x is less than 0. However, there's no solution, since there are no numbers that are greater than 6 and less than 0. Here's the second set. When we solve the first inequality, we get x is greater than or equal to negative 3. So this way. And if we solve the second one, we get x is less than 1. So here's 1 that way. The answer is all real numbers, since all the numbers are included in the solution set. All right, here we have another set. We solve the first one, we get x is less than or equal to 5. So here's 5, less than or equal, okay? If we solve this one, we get x is greater than 9. The answer is no solution, since there are no numbers that are less than or equal to 5 and greater than 9. Here we have two more inequalities. When we solve the first one, we get x is greater than or equal to negative 8. So here's negative 8. We go this way. When we solve the second inequality, we get x is greater than or equal to 10. So the answer is all numbers that are greater than or equal to 10. Translate the following applied problem application into a compound inequality. Solve and graph the solution set. The sum of 3 times a number and 2 lies between 8 and 11. This is an AND operation where the answers in the solution sets have to be greater than 8 and less than 11. Write and solve the compound inequality and graph the solution set. So 3x plus 2 must be greater than 8 and less than 11. So we can combine them into one compound inequality and solve for x. So first we'll subtract 2 from all three sides. So we get 8 minus 2 is 6, 11 minus 2 is 9. Then we divide all three sections by 3 to get 2 is less than x is less than 3. All right, so here's the graph. X has to be greater than 2 and less than 3. So we have two open circles, connect them with a line. A cell phone plan offers free minutes for no more than 250 minutes per month. Write and solve an inequality for the possible number of free minutes. Graph the solution set. Let m equal the number of minutes. This is an and statement since both inequality solution sets must intersect. M must be greater than or equal to 0 and less than or equal to 250. We can combine those together into one compound inequality that goes from 0 to 250, including 0 and 250. Lila has scores of 82, 92, 93, and 99 on her math tests. Use a compound inequality to find the range of scores she can make on her final exam to receive a B in the course. The final exam counts as 2 test grades, and a B is received if the final course average is from 85 to 92. Graph the solution set. Let T equal the required grade on the final exam. This is an and statement since both inequality solution sets must intersect. The average of the grades is the sum of the 4 tests plus 2 times the final exam grade divided by 6, because the final exam counts as 2 grades. So this is our equation for the average, 366 plus 2t over 6. There are 2 inequalities that need to be satisfied. We have the low bound for the average and the high bound for the average. So we need the average to be greater than or equal to 85 and less than or equal to 92. So we can combine and solve. So we combine, we're going to first multiply all 3 sections by 6 to get rid of the fraction. Then we'll subtract 366 from all 3 sides. Then we'll divide by 2 to get 72 is less than or equal to t, which is less than or equal to 93. Therefore, here is the graph of our solution. Lila has to get between a 72 and a 93 on the final in order to get a B in the class.